you how to solve linear equations using a general strategy. An equation that is a relationship that is true for some values of the variable. The values that make the equation true is called solutions. To find out if a value is a solution, substitute the value in for the variable in the equation. Determine if the value makes a true statement. If it does, then the value is a solution. If not, the value is not a solution. So example number 1, determine if the following values are solutions to the equation 3y plus 6 is equal to 5y plus 9. Part A is y equals -3/2. 3 times -3/2 plus 6 equals 5 times -3/2 plus 9. So -9/2 plus 6 equals -15/2 plus 9. -9/2 plus 12/2 equals -15/2 plus 18/2. Equals 3/2. Since this is a true statement, then y equals -3/2 is the solution to 3y plus 6 is equal to 5y plus 9. Part B is that y is equal to 5/2. 3 times 5/2 plus 6 is that equal to 5 times 5/2 plus 9. So that's 15/2 plus 6 is that equal to 25/2 plus 9. 15/2 plus 12/2 is that equal to 25/2 plus 18/2. "37/2 is that equal to 43/2. Since this is a false statement, then y equals 5/2 is not a solution to 3y plus 6 equals 5y plus 9. A linear equation in one variable is an equation where the variable is raised to the first power and is of the form ax plus b equals 0, where a and b are real numbers, with a not equal to 0. The letter a is called the coefficient, and the letter b is the constant. To solve a linear equation in one variable, there are certain steps that we can follow that can be used to solve all linear equations. The next example will demonstrate these steps. Example number 2. Find the solution to 2 times x minus 5 plus 3 equals 5x plus 5. So step 1 is to first simplify both sides of the equation as much as possible. This may mean use the distributive property to distribute, then collect like terms. So that will be 2 times x minus 2 times 5 plus 3 is equal to 5x plus 5. So that's 2x minus 10 plus 3 is equal to 5x plus 5, which is 2x minus 7 is equal to 5x plus 5. Step 2 is to collect all variables on one side of the equation. Add or subtract the variable term from one side to the other. In this case, subtract 5x from both sides. 2x minus 7 equals 5x plus 5 we're going to subtract 5x from both sides. That is minus 3x minus 7 is equal to 5. Step 3 is collect all constant terms on the other side of the equation. Add or subtract the constant term from one side to the other that does not have a variable. In this case, add 7 to both sides. So minus 3x minus 7 equals 5. We're going to add 7 to both sides. That's minus 3x is equal to 12. Step 4, make the coefficient in front of the variable into a 1. Either multiply or divide both sides of the equation by the number in front of the variable. In this case, divide both sides by negative 3. So x is equal to negative 4. Step 5 is to check your answer. Substitute your answer into the equation to make sure the answer is correct. So we have 2 times negative 4 minus 5 plus 3 is equal to 5 times negative 4 plus 5. So 2 times negative 9 plus 3 is equal to negative 20 plus 5. So negative 18 plus 3 is negative 15. Negative 20 plus 5 is negative 15. Here is the general strategy. Step 1 is to simplify both sides of the equation as much as possible. This may mean distributing to clear the parentheses, combining like terms on each side of the equal sign, multiplying both sides by the least common denominator to clear all fractions. Step 2 will be to collect all variables on one side of the equation. This means to add or subtract the term having a variable from both sides of the equation so that the variable only ends up on one side of the equal sign. Step 3 will be collect all constant terms on the other side of the equation. This means to add or subtract the terms without variables called the constant terms from both sides of the equation so that the variable term is all by itself on one side of the equal sign. Step 4 is to make the coefficient in front of the variable into a 1. You need to multiply or divide both sides of the equation so that the coefficient in front of the variable is a 1. The coefficient is the number attached to the variable by multiplication. And then step 5 is to check your answer. This is where we substitute the value we found for the variable into the original equation to make sure that the value is really a solution. This is completed for 2 reasons. One is that for future equations, there may be times when the answer you found actually doesn't make the equation true. It is called an extraneous root. You did everything correctly, but it won't make the original equation true. This won't happen for linear equations, but it does for other types of equations that you encounter later. The other reason it doesn't make the equation true is because you made a mistake in your solution. If your answer doesn't check, go over each step of your solution to make sure you didn't make a mistake. So example number 3, solve 2/3 n plus 5/2 equals a 7/2 n minus 2. The solution to this. Step 1, notice the equation has fractions. First, find the lowest common denominator between all the denominators. The denominators are 3, 2, 2, and 1. Remember, a whole number can always be put over 1. The lowest common denominator is 6 between the 3 of these. By the way, there is nothing really special about the lowest common denominator. You can use any common denominator. The reason the lowest common denominator is used most of the time is to work with smaller numbers. In the future, when you work with rational expressions, using the lowest common denominator makes the work simpler. First, multiply both sides of the equation by the lowest common denominator of 6, and then distribute. You have 6 times 2/3 n plus 6 times 5 halves equals 6 times 7 halves n minus 6 times 2. So this is 4n plus 15 equals 21n minus 12. Step 2, now you want to move the variable terms so they can be on the same side of the equation. Doesn't matter which side you move the terms to, pick the side you want. If you prefer to work with positive numbers, subtracting 4n from both sides. $15 is equal to 17n minus 12. Step 3, now move the constant term from one side to the other so the variable term is by itself. So add 12 to both sides of the equation. That gives you 27 is equal to 17n. Step 4 is you want n by itself, so you want to have the number in front of n to be a 1. Divide 17 by 7. N by 7 will make it into a 1. So divide both sides by 17. So n is equal to 27 over 17. Step 5, now substitute the answer into the original equation to make sure you get a true answer. The 2/3 times 27/17 plus 5 halves is equal to 7 halves times 27/17 minus 2. So that's 18 over 17 plus 5 halves is equal to 189 over 34 minus 2. $18 over 17 times 2 over 2 will get us a common denominator, plus 5 over 2 times 17 over 17 will get us a common denominator. Equals 189 over 34, that already has the common denominator, minus 2 times 34 over 34 to get that with a common denominator. So you have 36 over 34 plus 85 over 34 is equal to 189 over 34 minus 68 over 34. That gives 121 over 34 equals 121 over 34. So 27 over 17 is a solution to the equation 2/3 n plus 5 halves is equal to 7 halves n minus 2. In example number 2 and example number 3, there's only one number that makes these equations true. All other numbers will make the equation false. So these equations are called conditional equations, since getting a true statement depends on the condition of picking the correct value for the variable. By the way, in linear equations, there's only one answer that will make the equation true, but other equations, there may be more in numbers that will make the conditional equation true. Let's try another example. Example number 4, solve 2n minus 3n plus 2, 5n minus 3n plus 2 is equal to 2n plus 6 minus 4. So the solution to this is to first collect like terms. So we get 2n plus 2 is equal to 2n plus 2. Subtracting 2n from both sides gets 2 equal to 2. But 2 is always equal to 2, is always true. So no matter what number you pick for n, you will always get a true value. This is known as an identity. Anytime you solve an equation and get a statement that is always true, then the solution is every real number. Example 5, let's solve 3n plus 6 equals 3n plus 5. First, distribute to clear the parentheses. So 3n plus 6 is equal to 3n plus 15. Move the variable terms to one side of the equation. Minus 3n minus 3n gives 6 equal to 15. But 6 never equals 15, so there is no number that will make the equation true. This is known as a contradiction. This equation has no solution. Classifying equations. The previous examples all produced different types of solutions to the equation. Sometimes there was only one number that made the equation true, sometimes all numbers make the equation true, and sometimes there were no numbers that make the equation true. It helps to classify the equations based on the number of solutions the equations provide. Here are the names used to classify equations. Conditional equations. This equation is true for one or more numbers, but not true for other numbers. Identity. This equation is true for all numbers. Contradiction. This equation is not true for any number. It is important to be able to classify an equation as conditional equation, identity, or contradiction. These labels are true for any type of equation. This table will summarize the classification. So the equation type, if it's conditional, what happens when you solve it is you solve and you find one or more values that make it true, but there are values that will not make it true. The solution is those one or more values you found. In an identity, what happens is you solve and the result is an expression that's always true, such as 2 equals 2. So no matter what value you put into the equation for the variable, you will always get a true statement. The solution to this is all real numbers. Contradiction, you solve and the result is an expression that is never true, such as getting 6 equals 8. So no matter what value you put into the equation, you will never get a true expression. This one has a solution of no solution. Example number 5, classify each equation and state the solution. So the solution of this is, let's first distribute. So we get 6w minus 4 is equal to 6w plus 5. Now subtract 6w from both sides. Is minus 4 plus 5. This is never true, so this is a contradiction. And the solution is no solution. Part B, let's try 3a plus 5 equals 6a plus minus 4. First, subtract 3a from both sides. Is 5 is equal to 3a. Minus 4. both sides. Nine is equal to 3a. And then divide both sides by 3. It gives you 3 is equal to a. This is a conditional equation. And the solution is a equals 3. Example letter C, 5n plus 7 equals 5 times n minus 3 minus 8. So 5n plus 7 is equal to 5n minus 15 minus 8. I'm sorry, this was supposed to be 5n plus 5 times n plus 3. I apologize for that. So we get 5n plus 7 is equal to 5n plus 15 minus 8, which gets me 5n plus 7 is equal to 5n plus 7. Subtracting 5n from both sides, and you get 7 equals 7. 7 equals 7 is always true, so this is an identity. And every row number is the solution. And that's how you solve these.